In this particular video, we will go through some basic terms related to refrigeration. So let's start with this video. First of all, we will see the unit of refrigeration. The refrigeration effect, or simply refrigeration, is measured in unit called ton of refrigeration. It is also called as TR. By the book, it is the amount of refrigeration effect produced by the uniform melting of 1 ton of ice from and at 0 degree centigrade in 24 hours. In simple words, we can say that if we keep 1 ton of ice, that is 1000 kg of ice, at a 0 degree centigrade, and the refrigeration effect, or simply the cooling effect produced by it in 24 hours, is called as 1 ton of refrigeration. Now let's see the conversion of TR to the kilowatt. 1 ton of refrigeration is how much kilowatt? Since the latent heat of ice is 335 kJ per kg, latent heat is the amount of heat required to cause the phase change. In the definition, there is 1000 kg of ice and 24 hours is mentioned. Therefore, 1 TR is equal to 335 into 1000 kJ in 24 hours. 24 hours is equal to 24 into 60 minutes. Therefore, 1 TR is equal to 335 into 1000 divided by 24 into 60, and the unit will be the kilojoule per minute. So it is equal to 332.6 kilojoule per minute. In actual practice, 1 ton of refrigeration is taken as equivalent to 210 kilojoule per minute. We want the conversion of 1 TR to the kilowatt, so we have to divide the 210 by 60 to get a unit in kilojoule per second, that is a kilowatt. Therefore, 1 TR is equal to 210 kilojoule per minute, that is equal to 3.5 kilowatt. Moving to the next point, coefficient of performance, or simply COP. COP of refrigerator, it is the ratio of heat extracted in the refrigerator to the work done on the refrigerant. Therefore, theoretical COP of refrigerator is equal to Q by W. Here Q is amount of heat extracted, or amount of refrigeration produced, or the capacity of refrigerator, and W is the amount of work done. There is always difference between the theoretical COP and the actual COP. So new terms comes into picture, that is relative COP, and it is equal to the ratio of actual COP to the theoretical COP. Now let's see the COP of heat engine, COP of refrigerator, and COP of heat pump. To understand this COP, we will refer in general definition of COP. That is, it is the ratio of desired effect to the heat supplied or work required, that is the input energy supplied. For heat engine, the desired effect will be the mechanical work, mechanical output work. For the refrigerator, desired effect will be the refrigeration effect, or simply cooling effect. And for the heat pump, the desired effect will be the heat delivered. Now let's see them one by one. First, COP of heat engine. There will be the heat engine, there will be the hot body, it is also called as high temperature reservoir. There will be the cold body, also called as low temperature reservoir. In the heat engine, Q2 amount of heat is supplied from the high temperature reservoir to the heat engine, and it produces WE amount of work. Since it is not possible to convert all Q2 amount of heat into the mechanical work, Q1 amount of heat is rejected. So the WE is equal to Q2 minus Q1. So as per our general definition of COP, here the desired effect is output work, which is equal to WE. It is Q2 minus Q1, and the supplied energy is Q2. Hence the COP of heat engine, also called as efficiency of heat engine, is equal to desired effect divided by energy supplied, that is equal to Q2 minus Q1 divided by Q2. Now let's see the COP of refrigerator. In the refrigerator, WR amount of work is supplied to the refrigerator. It removes the Q1 amount of heat from the body which is to be cooled, and it is our desired effect, and the Q2 amount of heat is rejected. So the WR is equal to Q2 minus Q1. So as per our general definition of COP, here the desired effect is heat removed or extracted, which is equal to Q1, and the supplied energy or work is the WR, which is equal to Q2 minus Q1. Hence the COP of refrigerator is equal to Q1 upon WR, which is equal to Q1 upon Q2 minus Q1. Now last point, COP of heat pump. There will be the heat pump, hot body also called as high temperature reservoir. There will be the cold body also called as low temperature reservoir. In the heat pump, WP amount of work is supplied to the heat pump. Then the Q2 amount of heat is delivered to the body which is to be heated, and it is our desired effect. So as per our general definition of COP, the desired effect which is heat delivered is equal to Q2, and the supplied energy or work, that is WP, is equal to Q2 minus Q1. Hence the COP of heat pumps is equal to Q2 upon WP, which is equal to Q2 upon Q2 minus Q1. Now let's do one thing. Add 1 in the COP of refrigerator. The COP of refrigerator is equal to Q1 upon Q2 minus Q1. By solving this equation, we get Q1 plus Q2 minus Q1 divided by Q2 minus Q1, which is equal to Q2 upon Q2 minus Q1. It is nothing but the COP of heat pump. Therefore, we can say that the COP of heat pump is equal to COP of refrigerator plus 1. Thank you for watching this video. If you have any question, please comment below, and please don't forget to subscribe my channel. We will come with another topic related to mechanical engineering.